So we just dropped a new documentary. It's called How the Animal Kingdom Started. And it's about how life on Earth went from single cells to us. It took over 600 million years. It is one of our most ambitious projects yet. And I'm proud to say that it's under 90 scenes and 10 minutes long. So here's how we did it. First of all, let's talk about the scope of this thing. We wanted to cover over 600 million years in less than 10 minutes. That's around 60 million years per minute. To put that into context, if I was to speed up my video right now, I would be talking at roughly 60 million words per minute. If I was to write those words down, I would be writing at 60 million words per minute. And we needed to tell that story visually with no narration. Now, to do this, we cut out the fluff. There are no cute animal babies in this video. There are no sweeping drone shots of nature documentaries, no whimsical music or sound effects. This is an incredibly tight, fast-paced documentary. We used a style we call minimal realism, meaning that we didn't use any CGI or overly stylized visuals. But everything is instead presented in a way that is true to how we think animals and environments actually looked. This meant that we had to rely on scientific accuracy above all else. We also had to find a way to show complex concepts in very simple ways. For example, how do you explain evolution? Or how do you explain plate tectonics? Our solution was always the same. Show the evidence. Evolution is not an abstract concept. It's something that we can see happening today in fossils and in living animals. Plate tectonics isn't some invisible force. It leaves behind scars on the Earth that we can still see today. To pull this off, we sourced hundreds of fossils, minerals, rocks, and other natural objects. These objects were then photographed individually against a white background in a studio. We then stitched together many of these images to create composites that showed how things looked when they were first formed hundreds of millions of years ago. In some cases, we were able to find real examples of these things like trilobites, but in other cases we couldn't. So for those we created models and digital scans. After that, we spent months compiling footage from museums and research institutions that had similar visual styles to ours. We also worked closely with paleontologists and other scientists who helped us to make sense of the huge amount of data that we were looking at. In order to assemble all of this information into a cohesive story, we built a custom software platform that allowed us to move these fossils and environment plates around like pieces of a giant jigsaw puzzle. Once we were happy with the puzzle, we exported it as a video. The biggest challenge at this point was condensing all of this information into a 10-minute video while also making it as clear and understandable as possible. We began by creating a storyboard, which is basically like a comic strip version of the film. This took several weeks and involved drawing out every single scene on individual storyboards. With the storyboards done, we moved on to what we call animatics. These are basically the video version of the storyboards, but with temporary placeholder visuals. At this stage, the video was still around 20 minutes long. Now that we had a rough cut, we began working on what we call the science checks. Basically, every single claim that we make in the video had to be checked by a scientist to ensure that it was accurate. This was probably the longest part of the production process because we had so much information to check. Once the science checks were done, we got to work on the visuals. We replaced the placeholder images with more suitable ones, and we also added some graphics and text. We tried to keep the graphics and text to a minimum, but it was sometimes necessary in order to explain a complex concept. The next step was sound design. This involved adding a soundtrack and sound effects. The soundtrack was created specifically for this project and was composed by an award-winning composer. He did an amazing job capturing the epic scale of the story with just a few simple instruments. Sound effects were mostly taken from a library, but we did record some of our own as well. At this point, we had another round of notes. This is pretty standard for documentary filmmaking. Usually there are at least 3 or 4 rounds of notes. This is where you go back and add more information or change things around based on feedback. With the revisions done, the video was finally finished. Now let us take a closer look at some of the scenes in the documentary and how we brought them to life. This scene shows the formation of the supercontinent Rodinia. Around 1 billion years ago, all of the Earth's land was joined together in a single supercontinent. This supercontinent was called Rodinia. It's thought that Rodinia began to break apart around 750 million years ago. This process of continental drift is still happening today. In fact, you can watch the continents moving in real time on Google Earth. In order to show how the supercontinent broke apart, we created a computer animation. We started by creating 3D models of the different land masses. We then created a simulation of plate tectonics using a software called Trench. Finally, we animated the camera and added some simple lighting. The result is a dramatic and engaging visualization of how the supercontinent broke apart. Another interesting scene is this one where we show the evolution of early fish. Fish are a critical part of the story because they were the first vertebrates. Vertebrates are animals with backbones. This includes all of the major groups of animals, but also all of the smaller groups like sharks and hagfish. Until recently, it was thought that fish evolved from a group of invertebrates called tunicates. However, a 2020 study found that this was incorrect. Instead, fish are more closely related to a group of invertebrates called lancelets. In the documentary, we discuss this new discovery and show how fish may have evolved from lancelets. To do this, we created a short animation that shows the different steps in the evolutionary process. The animation starts with a simple line drawing of a lancelet. Then the drawing begins to take on more detail as the lancelet becomes more like a fish. Finally, the fish is shown in full color swimming through its environment. Next, we have this scene showing the emergence of the first tetrapods. Tetrapods are four-footed vertebrates like frogs, turtles, and eventually also mammals and eventually humans. The transition from water to land was a major event in the history of life. It allowed vertebrates to exploit a whole new environment and led to the evolution of some of the most diverse groups of animals. The first tetrapods are thought to have evolved around 365 million years ago. They were a group of fish that had adapted to life on land. Over time, these fish gave rise to all of the tetrapods that we know today. In the documentary, we discuss this transition and show how it happened. To do this, we created a series of animations that show the different steps in the process. The animations start with a simple line drawing of a fish. As the fish begins to adapt to life on land, the drawing becomes more detailed. Eventually, the fish has evolved into a four-footed animal. These are just a few of the scenes in the documentary. Each scene is unique and tells an important part of the story. Together, the scenes form a coherent narrative that explains how the animal kingdom started. The biggest challenge was condensing all of this information into a 10-minute video while also making it as clear and understandable as possible. The key to this was simplicity. We stripped away all of the extraneous details and focused on the big picture. We also tried to make the video as visual as possible. We used minimal graphics and text and instead relied on the power of the story to engage the viewer. We hope that you enjoy the documentary and that you learn something new. The goal of the channel has always been to make science more engaging and accessible, and this documentary is a perfect example of that mission. It took over 2 years to make this video. We hope you like it.